Before we start, I would like to mention that I am not a blockchain expert. I am not a certified programmer, as in I don't have a bachelor's degree or any certification. And I will just be using my problem solving skills and basic programming knowledge, so this will also be a learning experience for me. Now we're going to start off by setting up the environment. I will be using Debian Linux, but you can just use just about any Linux you want. And these are the basic things we will need: a compiler, CMake, so it builds our makefile, and I will be using the OpenSSL development package in this part only for the SHA-256 hash. I'm going to use this Debian Linux instance to be able to run the project. So first we would need to install the actual compiler. We will also need CMake and make. And libSSL for the hashing function. Well, it's not OpenSSL. There we go. Now to start out, we will structure this project. We will have a CBlock class, which will have the hash of that block once it's complete, the data that will be stored inside that block, and a pointer to the previous block. We will also have the CChain class, which will list out all the blocks in a vector and have a pointer to the current block that is be writing data to at that moment. So in the private sector of this class, we're going to have the current hash, which I will be storing it as a byte array with the digest length. We also have the previous hash. This would be the hash of the previous block, also a byte array with the digest length. This is a pointer to the previous block. It will be null in the scenario that it is a Genesis block. This will be a byte data of the transactions. Since we still don't know what type of data set we'll be using, we'll just make it byte array and store whatever we're going to store. And this would be the size of the data. This is a timestamp of when the block was created. And this would be the nums of the block. So here I'll be explaining the body of this class. This is the constructor. We will always be passing the previous block. And for the first block, it will be just null. This one calculates the SHA-256 hash. This will be storing the hash on this one right here. This just gets the hash, current hash, which is just returns basically mhash as a pointer. This gets the string representation of mhash. This gets a pointer of the previous block, just to be able to iterate back. This appends data to the transaction data. This is to mdata itself. This will return the difficulty. Basically, in this scenario, the difficulty will be the same difficulty we assigned to the chain. this will mine the block. The difficulty comes from the chain. This is just to pass it to the block, and this just gets a nonce value. Now I'll be explaining all the content of the functions. In the constructor, the first thing we do is when the previous block was passed, we set our current class variable and previous block to whatever was passed. I don't think we need to even add a comment to that. We initialize mhash. We fill it all with nulls with memset. If we pass the previous block, we copy the previous block's hash into the local one in this class. Copy previous block hash to current object's previous block hash. Yeah, that's what it is. If not, we just set it to nulls. We set the creation timestamp to whatever time it is at that moment. And this will just initialize all these in 0. And then we execute calculate hash with no data. This is really optional. I don't believe this would be completely necessary because the data size will change. But you can do it or decide not to do it. Now I'm going to explain the calculate hash function. Now first we have to determine the full size of what we're going to send as a payload to calculate the hash. So here we have this part would be, I'm going to put the comma here. This would be the size of the m previous hash. So basically the digest length per times a byte. The size of the timestamp, which is this one, which will also be adding into the hash. The size of the data should be mdata size, basically, which is stored in that variable, plus an integer, which would be the nonce. This is for the nonce. So we calculate that size and we generate a pointer of that size. Then we assign a cursor to the beginning of the pointer. PDR is just a cursor. So as we add memcopy data to this cursor, we just iterate it. So here I noticed that I added 20. This is actually wrong. This is, when I wrote this, it's just supposed to be the actual digest length. So I just corrected myself here. So we wrote that, we pushed that forward, we wrote the timestamp, we pushed it forward, that size, etc., etc. This is just writing the data to the buffer. Then here, this is using libSSL hashing functions. It's the most widely used hashing functions in C and C++. This is just standard APIs from libSSL. We assign a context, we initialize a context, we post a buffer into the context, and then we get the hash, which is written back to mhash, which is already allocated here. This next function just returns the hash. This is usually used for accessing the hash for the block. And this one here returns the string representation of the hash. As you can see, I'm iterating over the just a regular digest and turning it into hex. So this is basically hex format of hash. The next function is this just returns a pointer to the previous block. And here we append data. So to append data, since I'm not really using a packet buffer class, I wanted to keep it simple. I allocate a new data, which is the old data size plus the new data size. I put a cursor in the new data. And then if there was previous data, I put that old data in the new data where the pointer is. I delete the old data. And then I add the new data after shifting the pointer. And then I set the current data's pointer to the new data I just allocated and the size to the new size. Now here there seems to be another mistake. This size here actually should be, oh no, that's a plus, it's an increment I have. So this is fine. Here this will check if the difficulty when you're mining has actually reached the target difficulty. So this is just checking if the number of zeros in the hash matches the ones in the difficulty. It's a regular difficulty function for a blockchain. As my limited blockchain knowledge, I don't really know much of why it's done this way, but we'll find out as we go along. And here is a mining function. Now here I don't have any sleep. We might want to add a use sleep something, but we can determine whatever that is later on. This is so we don't hit the processor ridiculously hard and make the application crash. So we might have to add std here to use the use sleep function. I believe that one comes from uni std. And then this just returns the nonce, whatever values on the nonce. Now I'm going to explain the chain class. So I'll start with this value here. This is the list of blocks. This is actually the actual object allocated. This is a pointer to the current block. It basically points to whatever is on the last chain, so it would be basically, it's updated every time a new block is mined. And then the difficulty, that's passed to all the blocks. When you initialize a chain, you have to set the difficulty. I'm gonna use difficulty 0 just for all these tests, but we can later play around with that. This is the function to append to whatever current block. So basically just to add data to the current block. There's no point in adding data to previous blocks because they've already been frozen and hashed. So this is really the only a data appending function that you'll be ever using. And this function here continues to the next block. So basically close out the previous block and just create a new block. And this one just gets a pointer to the current block. Now in the body of these functions, when you start the construction of a chain, you want to assign the difficulty of that chain. So this should be self-explanatory. And then here is where we push the first block. This block is still not mined, we're just adding it as the first block. As you can see in the constructor, I'm sending null to the block as the previous block. So it's basically the beginning of the chain. And then I assign the pointer of the current block to the first element of the array. In append to current block, the only thing that's happening is we just grab the current block and call the append data for that block, which was already explained on how it works on previous minutes of this video. And then the next block, this would create a new block and set the current block as a previous block. then it would mine that block, and then it would push it to the end of the array and then sets the current block to the end. So basically it grabs the current block, sets it as the previous block, and then sets this new block as the current block. And then this just returns the current block that is on the chain. Now to test what we built, I'll run through the main function, a few of the things we've built. First, I'm going to initialize the chain with difficulty 1, and I am going to grab the Genesis block just to keep track of it. Here, I will generate some garbage bytes using time and modulus 255 just to put some garbage data. I will append garbage data to the current block, delete that garbage, continue to the next block, then generate more garbage, append that garbage to the new block, and then continue to the next block. This should be a basic test we can do. So here is the CMake file. This is a very basic to start out the project. We set the project name to Simple Blockchain. We set the project as a project name. We add all these source files. So basically I have the source files in source and source blockchain. We create an executable with the same name as the project, and we add the linked libraries SSL and Crypto. Crypto is a sublibrary of libSSL. So let's build our project. We would create a build directory to be able to run the CMake. Run CMake. That went well. And then we run make. Build. Perfect. And then let's run the blockchain. Here we go. So we successfully tested our blockchain. We had a Genesis block. We mined another block. Obviously, we still don't have any storage or networking, but we will go into that in the next video. So don't forget to subscribe and comment below if you have any comments you